All right, now we're recording. What are we going to do? I'm going to do a docker run -it ROS noetic robot. And then we're going to make a new one, docker ps docker exec -it goofy Goldstein. Goofy Goldstein. How did I know to do Goofy Goldstein? It's right here. Control C, bash, Dr. exec, not exect. There we are. On this one, I'm going to do source ROS entry point ROS core. And then I've got some more work to do over here, but source ROS entry point .sh. One new one, so where am I? CD work teaching CS 3891 CD source. Where is my data? CD work data. Here we are. Control C, docker copy this file to what was the name? Goofy Goldstein. Goldstein. My bag. Nope. It might have been. That would also be someone else's name. Okay, so now the file is there, ls-l. We got mybag.bag here, rosbag info, mybag.bag. And now I can see all of these things, including the messages that I have. So I'm going to start up Simulink now. MATLAB. Running MATLAB. While MATLAB is running, I'm going to go to Brightspace and download the bag files, or not the bag file, but the raw file that we were kind of starting with. I'm going to make some changes with it.
Please work. Okay. No, it's like every time I try and like.
Under special topics, course, content, simulation. Somewhere down here is car example template, and then car example template in class. I'm going to take this in class example here. I'm going to download it. And now I'm going to open up here, car example template in class, MATLAB. I'm going to now run Simulink, get Simulink going. While Simulink is starting up, I'm going to go to my teaching directory here, work, come on. Here we are, work, teaching CS 3891 2023 source. Okay, I have something already here called car controller. We're going to make a new folder in class because namespaces matter. And so in this folder, I'm going to copy that file. So Control C, work, teaching 3891 source in class, Control V. All right, now we've got CC car example template. We're going to go ahead and open this. This will open in Simulink. While that's opening, I'm going to run ROS init. This is what's tricking up a lot of people right now. So I'm going to run it here. You should eventually see something that looks like this. If you don't see this pop up whenever you run it, it means that there's a Python environment problem, and we have at least a couple solutions out there that are floating for this. All right, somewhere I have Simulink popped up. There's a double click finally worked here. And now I'm just going to modify this so that it runs with generated code from ROS in order to change. I have to change just a few parameters. And again, I'm recording all of this for those of you who have just got in a few minutes ago. I'm going to post the video to YouTube just as soon as we finish. So if you say anything, you're going to be on YouTube forever. Sorry about that. All right, scope, I don't need it. Library browser, I need it. What do I need to add? I need to add inputs. I need to subscribe. ROS toolbox, ROS, subscribe. Here it is. What am I subscribing to? Car state vel x. I'm not going to select it from a ROS network. I'm going to write it myself. Car state vel x. And this is of type standard messages float 64. There we go. Okay. Okay. I'm going to take this guy off of here and move him up to here. This just never works with a trackpad. I don't know why. If you've got a regular computer mouse, that works every time. All right. And I'm going to connect you now. There we go. Okay, and I'm going to do something else too. I'm going to add a publisher. So I want to be publishing a message on the other side. The topic that I'm going to publish, you can make up whatever you want to. My topic is going to be car state vel or state slash, and then this is simulated, or let's just call it sim vel x. And the output type, again, standard messages float 64. Now, in order to publish something to this, there's a little bit of magic that I'm going to show you how to do here. There's a bunch of tutorials that show how to do this online, including some that are from my YouTube channel. So I'm going to create a blank message here. The blank message is of kind, again, that's something you should just be able to type, and I don't know why it doesn't. The type is standard messages float 64 because that's what we're publishing. All right, and I'm going to create, okay, I'm going to add my data coming out into the data field that belongs to this message. And to do that, I think I'm not going to get it from inside the ROS stuff. I'm going to get it from inside of, if I search for bus, there's this bus message type here, bus assignment. So I'm going to drag in bus assignment. I'm going to connect this output bus to be the data output here. The input to the bus comes from here, and the signal to the bus comes from the velocity output here. So the output velocity that I'm telling is what I want to publish as this value. And it's not going to be called signal 1, it's going to be called data, because data is the data field that comes from that message. So now I've basically done everything I need to do to be able to generate ROS messages from here. I'm going to go next to my modeling, and I'm going to change just one model setting. That model setting is going to be that my hardware is of kind robot operating system. Okay. Now that I've updated that to be my robot operating system, I'm going to check the parameters one more time. What solver am I using? Start time 0, end time 400? No, end time forever. It's going to run forever. It's going to be running fixed step solving. I'm going to make it be discrete, and I'm going to have this run every 0.1 seconds. You can do it with just standard continuous time if you want to, but I made it discrete. And now I'm going to build the model. This is going to work because I did ROS init, and that starts up its own ROS framework, so it will generate the code. This generated code will be a TGZ file that will be in the folder that I'm running the simulink thing from. Okay, so now I get an error. What does it say? The fixed step discrete solver cannot be used to simulate block diagram because it contains states. That's cool. All right, well, we're going to go back to, nope, not to there. Stop, 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 stop. We're going to go back to my model parameters, and I'm going to change it from fixed step back to continuous. Discrete step back to continuous. Auto. This should work just fine. We're going to make this be auto as well. I did this earlier today to make sure it works, but that was an audible that I called, so that was probably a mistake. I'm going to get another error now. It's going to tell me that I can't use the integrator block, probably. Or it's going to be just fine. Yep, here we go. To prevent this error, modify the system object code to avoid code that does not do it. So the MATLAB system block, read data, source block. Oh, okay. Yeah, it doesn't like the fact that I've got these bag file things. So I'm going to delete this and delete this. I'm going to run one more time. That might actually have been the error that I got before and I didn't realize it. Okay, a signal is not a bus signal. The output to the bus selector must be virtual or a non-virtual bus signal. Okay, we're going to delete this part too. That may fix that. Starting build procedure. Something is not connected. That's fine. I'm not using it anyway. All right, here we go. This integrator uses continuous time, which is not supported. But here it says suggested actions, select support continuous time, or I'm just going to click this fix button. So fix, I want to fix that error. One more time, I'm going to run the build model. Most of the time, these things will just work magically. And what I do is that I have a block somewhere that I run in Simulink, and then I paste that into my ROS model when the time comes. So now the code generation itself is running. You can see that it's constructing the code from the Simulink model here. This will take just a few minutes to go. It's generating C and C++ code, and it's generating it in a way that you can run on ROS, what you need to do. So why am I doing all of this? Well, I'm doing all of this because I want to be able to use the boxes and lines that we developed here, that we prototyped, that we know seem to work from a ROS bag, and have them work there. So going back now, it says that my build is done. Code generation information file has been successfully produced. And from a folder that if I go to cd work teaching CS3891 source cd in class, I now have this tgz file here, cc car example template in class.tgz. So I'm going to copy this to my Docker container. Docker copy this file to what was my name, Goldie Goofy Goldstein. Control C, Goofy Goldstein, colon, cc car example template in class.tgz. Okay, that's copied there now. And here is my TGZ file. So the only thing that I haven't done that I actually don't know how to do is how to create a ROS environment here that's going to enable me to use this thing. So I have to go through some intermediate steps to create my ROS environment. Let's do make dir ROS, cd ROS, and then I think it's catkin, so make dir source, cd source, and then catkin create catkin create workspace. Who remembers this command? Catkin create workspace. Make dir-p catkin workspace source catkin make. Okay. Catkin make. So all of this generic stuff gets done, cd source, and then in this folder, I need to copy the TGZ file here. Oh, nope, that was unfortunate.
You forgot to tell it to
ROS. Yeah, I didn't give it the source, and so now copy ... cc car example here, tar xcf cc car example, and now I've got a folder cc car example template in class, catkin make source ROS entry point, catkin make.
Just go back.
Yep. Oh, nope. Womp womp. Okay. Source ROS entry point. It's not robust when you make an error and it returns standard error that's not 0. So, bummer. cd ROS catkin make.
Wait, so if anything in Docker returns an error code, a non-zero error code,
It just quits.
In this case, it does. There's probably a way to fix that. I haven't fixed it yet. Now, what are we doing? What are we doing? Docker exec-it goofy Goldstein bash here. ROS bag play mybag.bag file. Oh, source, ROS, entry point, ROS bag, play mybag.bag. We're playing the bag file. From here, I'm going to do ROS run, cc car. Oh, womp womp. Okay, one more time. Source, ROS, entry point. I think now I need to do cd ROS. Oh, heavens. Cd ROS, and then source devel setup.bash. And now I think I can run ROS run, or ROS node list. No, I don't have any nodes running now. So now I'm in trouble because when I've been doing ROS run in the past, I just do ROS run and then I start hitting tab until I find the name of the package that I want to do. And it's failing for that. So ROS runs cc car example in class, and then tab one more time. There's the name of the model. So now my model is running. I'm running the model of the generated code that I had. The bag file is still running. Docker exec-it goofy Goldstein bash. ROS topic, nope, source, ROS entry point, ROS topic list. You can see I've got car state vel x and car state sim vel x. That's the code that I wrote. ROS topic echo car state sim vel x. So this is producing now, just like we had on Simulink. It's producing the code that interprets whatever it was that was happening there, but this is now generating the simulated output, just like you saw in that scope. But if we needed to go run this on the car right now, we could just take this code, put it on the Raspberry Pi in the car, and it would run. It would get its data instead of from the bag file, it would get it from the car itself. And if we were executing an output command that told the car how fast to go, the car would move. So, okay, I said 5 minutes, it took 19 minutes. This is where I want everybody in here to be at the end of the day today. You saw me do it directly from the files that we downloaded from there. You saw me do it within the MATLAB that we have. You saw me copy everything to the Docker container that we needed to do. So while we're working it, go back in time, find the link on YouTube, which I'm going to post into Brightspace, and then run with it. If you're having problems with running any of the technical things that you saw, put up your hand. Either Nate or I will come by. Mary solved some of the problems before too. I'll call on you in a minute when I turn the audio off. This is going to be awesome today, y'all. You're going to all make the change, make the switch happen. Once you get it done, or before you get it done, if you have a question about project, see Professor Work, because he's going to be crushing that today.